You're on the Nevada side of the dam. You're within the canyon walls and you're standing over a 30-foot diameter penstock pipe. It can have as much as 96,000 gallons of water per second flowing through it. You may feel a little rumbling under your feet. Hear that humming noise in the background. That's the water moving through the pipe. To give you a little better idea of that amount of water, it would fill an Olympic-sized swimming pool in about 7 seconds. Now what I want to do is take you guys back a little bit before the construction of the dam. First thing they needed to do, divert the water in the Colorado River. In doing so, they constructed 4 diversion tunnels, 2 on each side of the canyon walls. They're each 56 feet in diameter. They're about 4,000 feet long, and they're lined with concrete 3 feet thick. It took them almost 2 years to complete them, and this is one of those tunnels you're standing in right now. They also built 2 earthen dams, the Lower Coffer Dam and the Upper Coffer Dam. The Upper Coffer Dam, 100 feet high, forced the river into those diversion tunnels and around the job site. The Lower Coffer Dam, about 65 feet high, prevented the water from backing up into the site. Once the site was ready, they constructed the dam. It took them another 2 years to complete the dam. Now, once the dam was completed, they sealed off the entrances to those diversion tunnels with heavy steel gates, which then allowed the water to start backing up behind the dam. The Upper Coffer Dam is still there, and it serves a purpose to keep the silt from backing up behind the dam. The Lower Coffer Dam, though, was blasted away to allow the natural flow of the river downstream. It took 6.5 years for the lake to fill behind the dam. Now it is a river and it has to flow. So to get the water from the lake downstream is where the intake towers come into play. There are 4 of them, 2 on each side. They're each 395 feet tall, and they sit on ledges 250 feet above the bottom of the lake. Water flows into the intake towers, drops by gravity into those 30-foot diameter pipes at the base of each tower. Then the water is diverted into 13-foot diameter pipes, which lead to the generators to produce the electricity, and then the water is just simply emptied out into the tail race and continues its natural flow downstream. Water will not go over the top of the dam. It was designed that way. Now the spillways, 1 on each side, are there for flood control. They're 27 feet lower than the top of the dam, and they've actually only been used twice since construction was completed. Once in 1941 as a test, and again in 1983 they were put to the test. The accumulated snowmelt of the Colorado Rockies flooded the entire Colorado River. Water came in and filled the lake to within 7 feet of the top of the dam, spilling into the spillways, bypassing the entire facility and emptying safely downstream. It took 62 days with a force like Niagara Falls going over those spillways before the water finally went down. I lived in the area at the time, still do, but I went down there and saw it. It did have that force going over those spillways. It was amazing to see. In fact, there's a photo of it here. You can see how close it did get to the top of the dam. This is a picture of the Nevada spillway. Now what I want to do is give you all a better idea of where we're going to be on our second stop. We're going to get in the elevator, very short ride. We're going to come out at the power plant. It's the U-shaped structure at the base of Hoover Dam. We're going to be on the Nevada side of this structure. So keep this in mind. When we do get there, I'll refer to it once we're there. You guys ready for your second stop? Let's do